good morning, good afternoon, good evening, depends where you are. Today's topic is mastering performance optimization. My name is Pavel and I will take you through the webinar. So let's move to the agenda. We'll start with basic principles. We will look at how flow monitoring works, and we will look into network performance metrics. What are those metrics? How these metrics are being computed? And then we will take a look at a live troubleshooting case where we will basically use those performance metrics to determine the root cause of a performance issue. After that, I will then show you a couple of tips and tricks that you can use when you are analyzing the data or when you are building reports, when you are configuring your alerts. So we will go through a couple of practical items and I will show those on a live demo environment. So flow monitoring principles. What is flow data, or how does that concept work? Flow data is a specific network telemetry that allows you to understand the network traffic in detail. It basically captures all the network sessions and it provides metadata about these sessions. And with the metadata, you are able to reconstruct how the traffic looked in each and every moment in time. So you will be able to understand bandwidth utilization, performance metrics, and you are able to drill down to individual network connections between hosts to troubleshoot an issue in detail. So let's start with how these flow records are actually being created. Let's say these are our clients and we have a server. And these clients communicate with the server. So traffic is passing through the network, through routers, switches, whatever infrastructure is there. And let's say that one of those routers is actually configured to produce flow data. It means that the router will look inside the packets and will extract information such as IP addresses, ports, and protocol to determine individual flow records and build those records in something that is called a flow cache. So it's a specific memory inside of the router where individual packets are being aggregated into flow records as these packets are actually traversing through the router. And as you can see, these individual flow records represent unidirectional traffic, meaning all packets with the same source IP, source port, destination IP, destination port, and protocol will be aggregated into a single record. So one network session will be represented as two flow records and aggregated information like amount of transmitted data, number of packets, or duration will be aggregated as the packets are flowing over the network. There is an important concept called active and inactive timeout that controls how the data is actually being exported from the flow cache to the collector that is then processing, aggregating, visualizing, analyzing the data. So these active and inactive timeouts are important to be notified about the network traffic in timely manner. What I mean by that is that in case of standard TCP sessions, when this session is terminated, then the flow record is being exported to the collector. But that's only one reason why the flow can be exported. Another reason is the active timeout. So in case of a long lasting sessions, like for example, SSH sessions or FTP data download or data transmission session can take even hours, and you don't want to wait about like when the session is over to get information about the network traffic. So there is this active timeout, which is by default 5 minutes, and that ensures that every 5 minutes the flow record from the flow cache is actually being exported to the collector, so you have continuous information about the network traffic. And last concept is inactive timeout, which basically means that if there is no more traffic for the specific flow record, meaning that flow record was not updated for the period of inactive timeout, which is by default 30 seconds, the flow record will be exported to the collector. So this mechanism ensures that you will be continuously informed about all the network traffic, and you can reconstruct how the traffic look like over time. With flow data, sometimes people don't really understand what this technology can do for them. So sometimes there are myths like that it doesn't provide sufficient level of detail when it comes to network troubleshooting and forensics, and maybe you need full packet traces to be able to address the network issues. As you will see today, it's a completely different story. You don't need continuous packet capture to sort out your network issues with flow data, especially when it's combined with network performance metrics and visibility into application layer. You're able to sort out maybe up to 95% of all the different troubleshooting cases. And with the current explosion of bandwidth and throughput, packet capture tools really cannot scale with the volume of data that is being transmitted in the corporate networks. So that's why flow data are the ideal compromise between the level of depth and the required resources and the required performance and data storage and these other performance metrics. So let's move on into understanding what are network performance metrics. The ultimate question that you are trying to answer when it comes to the troubleshooting cases, is it the network or is it the application? So basically, you are trying to distinguish between network-related issue and application or server-related issue. For this, we have two key metrics called server response time that corresponds to the server or application delay, and round trip time, which corresponds to the delay introduced by the network. There are also other metrics like, for example, retransmissions that indicate that there are some packets being lost or not being processed properly and needs to be retransmitted over the network, which is another indicator of network issues. So how are these performance metrics computed or calculated from the network traffic? So when you have a client that is establishing a TCP session with the server, you measure a so-called TCP handshake, and from that you're able to determine the network round trip time, which basically means time required for packet going from the client to server and back. Then when client places a request over the network, that request is acknowledged by the server and first data packet with the response is provided. You can measure the time between the request and between the response, and you can approximate the server response time. And then you can also measure delays between the packets, and you can calculate jitter out of that If you are interested in more details or exact definitions of these performance metrics, we have it explained in detail in the Flowmon user guide. So now let's move from the theory into the live troubleshooting case. So imagine the following situation. You perform, or the supplier performs, an upgrade of a system that you are using for order processing. After that upgrade, you start to observe and experience performance degradation that impacts your users. It's being escalated, it has attention of the management, and you try to sort it out with the supplier, whose first initial response is, that's not us, that's your network, it's the network. When you look at the operational status, servers are running, requests are flowing through, so you don't really have any hard evidence at hand to prove that it's not the network, it's the application. And you have no way how to call the supplier accountable and responsible for the issue. But if you do proper network performance monitoring, you can understand these performance metrics in detail. You can distinguish between the delay introduced by the network and delay introduced by the application, which is exactly what we're going to do now, step by step. Before I switch to live demo, I'll need to explain my application topology, so you will then better understand the data that you are seeing. So I'm running something called my app, which is hosted on a specific IP address terminated on the load balancer, and that load balancer is ensuring high availability and redundancy, or also load balancing, as the application as such is hosted on 2 real servers with IP addresses ending 23 and 24. We also have 2 clients in the network that are basically simulating real users and that are generating traffic against this my application. And we're monitoring the network traffic on the client side, on the server side, so we have a detailed understanding of what is happening in the network, and we have our network performance metrics. So what we are going to do now is to look at the performance metrics and compare the situation before the system upgrade, after the upgrade, and we will compare the data from these different time intervals. So let me now switch to live demo, and I'll go to my dashboard. And on my first dashboard tab, I have a comparison of performance KPIs and some alerts. So I can immediately see that what is actually fired alarm is degradation of server response time, while round trip time and retransmissions are green, and we don't see issue in those. So that's a first indication that there is a problem on the server side. When I compare the application KPIs for last 24 hours and last 1 hour, I can immediately see that there is a huge difference between server response time in 24-hour average and in an average for last 1 hour. It's like 22 milliseconds versus 1.5 seconds. Let's drill down into more details. So in this detailed My Application Dashboard tab, I have my application topology, and I understand bandwidth utilization between individual application components. So I have here the aggregated traffic between clients and between the load balancer, in fact, and then the load balancer and pair of real servers that are hosting the application as such. I can see the traffic chart for these individual traffic components. So there is a huge degradation after 2 p.m. today when I actually deployed an upgrade to the application. Now, when I look at the application KPIs, and let's look at last 2 hours, for example, so it will be more obvious. I can compare now performance metrics for these individual components of the application. So let's start with this server. Round trip time 0.3 millisecond, round trip time 0.3 millisecond, basically no difference. This looks all good. But when I compare server response time, I can immediately see the difference of like 1 millisecond and 683 milliseconds. So the issue is actually on one of those servers, on the real server 24, and it's not the network, it's the application as such. So what I can do, I can now drill down into more details. So when I zoom in, I get my monitoring center view where I can see this application traffic, and let's bring the performance metrics. So we can see that in this moment, the performance degraded. So when I look at the statistics now, I can see that I'm having server response time for this server on level of 2.5 seconds, while this server is serving the application workload with a very reasonable server response time. Let's do some drill down. So in this case, what I would do, I would start with, let's say, IP conversations, and I want to see average server response time. And it shall be no surprise for us. So this is the server 24 serving the traffic with 2.5 seconds of the average server response time. We can actually drill down even further. We can say, give me first, let's say 20 flows. And so I can see that when I'm sending the real requests against the application, I'm getting this crazy 3 seconds server response time. But when the load balancer is doing health check of the server as such, it's being responded in a very reasonable time frame. So this also indicates that it's not the problem with the server as such, like being overloaded, for example, but it's really something wrong in the application. And here you have evidence at hand that you can show the correlation when you rolled out the application update and when the performance was degraded, and you can drill down to the level where you can understand which specific component of that application is responsible for that issue. So what I'm going to do now, just very quickly, I'm going to roll back this update. So you will in a few minutes see how this actually will return to normal. And in the meantime, I'm going to show you a couple of these tips and tricks that I've promised. So we'll start with some hints what you can use when you are analyzing the network traffic. So there is a way how you can navigate through the analysis results. So if I want to go back in my previous aggregated view, I can just navigate back here and say, give me the result of the previous result that I just had in the analysis in the past. Then what you may want to do as well is to send some sample report out of this view to someone. So you click on this PDF icon and it will generate you a PDF file that's basically capturing the whole screen of the analysis. So then you have an export from your analysis that you can share with your colleagues or with the supplier. So let me just open that generated PDF file. So this is what you get. You will get the traffic chart and you will get the result of the analysis. So this way you can easily share the result. Now, another thing that I want to show you is actually how you can customize the level of detail. So let's see, this is the current information that I see in the table, and that's determined by the output. So if I change the output for, let's say, extended network performance metrics, I will get more of these network performance metrics like round trip time, server response time, retransmissions, all the details. So you can control what level of detail, what information you want to see by editing these outputs, and you can basically say which columns you want to see in the table and in which order you can move the order of the columns. So this way you can customize the output of the analysis. Now I will move back into dashboards and reports, and I'm going to give you some tips on alerting. So here you have seen these alerts, and the way how I've created these alerts is actually functionality called presets. In addition to like understanding the network traffic for specific applications, there is also a specific preset for network performance metrics alerts. So you can actually take this preset, or maybe let me go back and show you what it actually contains. So this preset will create 3 different alerts, one for retransmissions, one for round trip time, and another for server response time. And you can apply it on any profile that you have configured so far. So when I say I want to have this preset applied, I'll just need to say it's going to be applied on, let's say, real server 24 traffic only. And I say install. And now it will create for me network performance metrics alerts that will notify me about significant deviations in performance metrics. So let's review those. So as you can see, these are the alerts that were created. And when we look at server response time, for example, here is the definition that says if the server response time will go up 100% compared to average for last 1 hour, that's something you can customize, of course. Then the alert will be triggered. Next tip that I want to show you is how to build your application topologies. So you have seen this view that is basically mapping network traffic in this topology graph where you have nodes that represent different, servers, switches, routers, sites, network subnets. That completely depends on what you want to model. And edges between these nodes are mapped to the network traffic. This functionality is called topologies. And so when I open this topology, you can see that this link between the load balancer and the real server 23 is actually defined in the way that it's mapped to profile my app and channel real server 23, and it has defined maximal bandwidth 100 megabits per second. This is the number that the system is then using to show you utilization, which is represented by a color. So, for example, if I do this, I'll change it to 10 megabits here. We will see that the line is immediately red, and the system is indicating that you have an issue with the bandwidth utilization. And you can add any components, any nodes into the topology and connect those with links and map it to the network traffic. So if I do here something completely artificial, I can add a node that will represent some router, and then when I create the link between these two nodes, I can say that it will be mapped to this profile called all sources and all channels. It has, let's say, 100 megabits per second bandwidth capacity. Oh, sorry, I'm not sure what I did wrong, so let me fix that. Yeah. So we can see here 3.1 megabits per second is the average for last 24 hours. I'm not limited to average. I can say maybe 95 percentile is better for me. So that really depends on what traffic or what application workload is that. So when I go back to the dashboard now, we will see here this router as well, and it's with the 95 percentile, it tells me that it's 16.4 megabits per second. So this way you can build your different topologies for applications or even for individual branch offices and connect those to the network traffic. Now, when you build your dashboard, last thing I want to show you is how you can easily convert this dashboard into a report, because usually you want to leverage this information for reporting as well. There is a specific feature hidden here on individual dashboard tabs. You can say create new report, and it will take all the widgets on the dashboard and it will place them into report as report chapters, where you can of course adjust, customize whatever you want. And then when you say create report, it's immediately created. And when you view that report, you can see that it's basically the content of the dashboard now in the form that is way more suitable for reporting. You can export into PDF, or you can configure scheduling. So this way you really save time in building your reports, because you can start with what you have already created on the dashboard. Okay, so I'm not going to wait for this. Let's get to some conclusions and questions, if any. Before we do that, maybe last thing that I want to demonstrate is how the application traffic get back to normal, how the performance metrics went back to normal values for all the servers, because I roll back the change on the server 24, and now the traffic is actually being, let me show you the detail, the traffic is now again back in normal. So let me do it now this way. So you'll see that these individual requests are now being responded very, very quickly as expected. Okay, so that was the content for today. And now it's time to answer any questions that you might have. Can you please record the session and share the link? Yes, as I said, the session is recorded and will be shared. Okay, then we have a comment. Okay. In demo, we can see load balancer. It will show any or only progress. Yeah, this is not really connected to Progress load balancer. This will work for any network traffic whatsoever because it's monitoring the network traffic through Flowmon probe. So you're not dependent on a specific routers, switches, load balancers. It will work in any type of the network. Then we have a question for server response time. Is it necessary to use application performance module? As you have seen, we didn't cover APM module at all. You don't need APM to measure round trip time, server response time. These are all network performance metrics. I don't even have APM installed on this system at all. So you don't need application performance monitoring to do analysis of server response time, round trip time, and the performance metrics in general. APM is actually building on top of that by reconstructing TCP sessions, extracting individual web-based or SQL-based transactions, and providing details into like all the parameters of the request, status code, network transport time, application response time, SLAs. So it's way more detailed for a selected subset of applications. There is also a question on a link to some guides for more detailed analysis options. Let me just show you the documentation docs.progress.com. There is a Flowmon, and when you go into Flowmon, into the user guide, you will actually see here all the details in the monitoring center filter syntax. So this way you will actually get all the details for advanced analysis. What filters can you use for all the application protocols? Everything is available in the public user guide. Is in the user guide how to set up the network topology view? I think so. So I just used search to get to the topology view, and here are all the instructions how to set up the topology. You can see that you can even use a physical, like, geographic map as the background. So yes, it's in the documentation. Okay, I don't see any further questions. Thank you for attending the webinar, and in 1 month, let me invite you for another one that will be focused on how to analyze events in Flowmon ADS. Thank you and goodbye.